Thanks, guys. Hopefully everyone can hear me. You can say in the chat if you can't. So my talk is maybe somewhat controversial because I think it's quite obvious that there might be some downsides to having multiple languages in your code base. But I think also with the kind of growth of microservice architecture, this might be less of an issue. So basically, my company had quite a number of requirements for picking a language to develop our product in, and there isn't really a one size fits all. So we kind of were looking at what kind of value we could get from mixing and matching, and also kind of how we can do that mixing and matching. Um, a few caveats before I get started. Because I'm talking about languages, I know that there's a bit of an inevitable, oh, but have you tried this one? Um, no, I probably haven't tried every language, but I'm very open and happy for advice on other languages that I should get to know. So feel free to put those in the comments. I picked these particular languages for reasons that I'll discuss in the presentation, and hopefully I'll be able to outline the kind of criteria that I have for reviewing them. So a bit more professional background about me. I originally studied mathematics and economics, and for the last 8 years or so, I've been building and deploying, you can call them advanced analytical models, machine learning models, also as a consultant. Because of that consultancy background, it means that I've been kind of put into teams with many different data scientists, different data engineers, loads of different data challenges and deployment challenges. I've been lucky enough to work in, well, over 15 tier one or global banks and insurance companies, which means, again, I've kind of met many different problems and challenges to overcome. A bit more personal stuff. So I'm originally from the UK, which you can probably hear in my voice, but I now live in Utrecht in the Netherlands. I started Nights Analytics by myself 2 years ago, originally just to do some freelancing consultancy work. But I had the niggle in the back of my mind that I had a good idea that I wanted to turn into a product. So I was developing that on the side. And it was the beginning of this year that I decided to actually put the time in to launching my business as a software company. So we build entity resolution algorithms, which is essentially kind of knitting together and pulling together siloed data to give a single view of either individuals or businesses. So a bit about our needs. We often dealing with really high volume data, and we are building these distributed knowledge graphs. So there were a few core components. We needed stability, scalability, speed, and simplicity, which I think is the core for any good enterprise software. But we also needed great data science support, as AI is kind of built into multiple parts of our product. So during the presentation today, I'm going to look through the kind of strengths and weaknesses of all of the languages and talk about why we went for a combination of Go with Julia and or Python. And then I'll show you a very high level architecture of essentially how we got them to work together. So the first criteria I was looking at is adoption and libraries. The question I was trying to answer from a business and technical point of view was, is it easy to get started? How is the support of these libraries or languages going to be? Will I be able to hire people to do these jobs? And do we think it has longevity? You can see the two graphs that I've put in. The first one is Stack Overflow trends graphs, which actually show the percentage of questions asked in each month for the given languages. And you can see that Python just far overshadows Go and Julia. I think that's to be expected from what most people know about Python. When you zoom in a little bit onto the Go and Julia lines, you see this kind of drop off from 2019. I was initially a bit surprised to see that from a Go perspective, but it looks like actually because it's a percentage of all questions asked, the sheer growth in both JavaScript and Python mean that almost any other language has this same dip. So it's actually not as concerning as it looks. The second graph is around modules. So how many libraries are there available? And again, Python massively overshadows. So from the Go point of view, a lot of what we needed is actually available, but it's still comparatively smaller to some of the more mature programming languages. Really nice little tidbit is that Kubernetes is written in Go, so that gave me a bit more confidence that it might be sticking around. Julia definitely has far fewer packages, much smaller community, and I'm a bit concerned about the fact that it looks quite stagnant. I'm not sure that I've seen the growth that I would hope to see if it was a language that I wanted to, rely on heavily for my software product. And then Python, as we all know, is general purpose, easy to learn, easy to use, super amount of support, and the adoption is massive. I've got a second graph that was a bit tongue-in-cheek. So I found this also whilst I was putting this deck together, which was a percentage of developers who are developing with the language or technology and where they've expressed interest in continue to developing with it. You can see that Python, Go, and Julia are in the kind of top 6 of those. And then you can see a list of all the languages that have maybe given a few more headaches over the years. So the next criteria I was looking at is performance, speed, and execution. And this is where both Go and Julia really shine. So I found this nice website, which I think a lot of people are maybe familiar with, called Benchmarks Game Team. And they have a number of different programming challenges, let's say, and that they kind of race languages against each other. In almost all cases, Go and Julia perform very well. Sometimes Go beats Julia, and in some cases, Julia in fact beats Go. There was only one test on that website which Python actually beat any of those two, and that was the regex test, where they basically have to use a simple regex pattern to manipulate a data format. So what did this mean for me? So Go, the performance was super high. Typically seen in these statically typed languages. It is compiled, which some people complain about, especially during development, but it's super quick to compile, so it's almost not noticeable. For Julia, the times were exceptionally fast, especially for in the pool of languages that Julia is typically chosen from, which also includes R. You can see that the speeds are C-like, or C. That's what I guess they sell themselves as well. I would say that what I've put here is that Julia is not just a compromise. It is like quite outstanding in its speed. But again, people have complained that the startup time can be slow. And I didn't want to completely bash Python. I think that some of these tests also have to be done with a grain of salt. There is certain things that Python does really well at, and there's been a lot more interest in Python speeding things up. So I think that there's a general consensus that for prototyping, there's not a lot better. Python is very easy to use. The lack of types mean that you don't have to check a lot of things. You don't have to be super precise, and you can still get something working. But I think it's hard to ignore how it's slow compared to other languages. Okay, scaling. So when I'm thinking about scaling, again, I'm looking at, will my program, when I'm handling massive volumes of data and running on various different machines, will it be able to handle the volume? Will it be able to meet SLAs? Can it utilize the processing power that I actually have available to me? And I've kind of put two important factors in measuring this, which is the whether a language processes with threading or multiprocessing. So for Go, it's really built into the language. It specializes particularly in threading and concurrency. There's a lot of love out there for the Go routines and channels that are built into this language. Um, it makes it very easy to, even for people who maybe haven't done threading before, because it's so intuitive. For Julia, actually, I was reading that they took a lot of their inspiration from the Go architecture as well. So you see a lot of the advantages that Go has in Julia as well. They have, well, they claim that they have three types of main features for this concurrent and parallel programming. Um, and it's not seen so much in Python. So for our use case, there's a famous global interpreter lock that a lot of people talk about that some people don't care about as much. For us, it just wouldn't be applicable for a lot of our software. I read this interesting quote that all a GIL does is make sure that one thread is executing Python code at a time, which seemed a little bit counterintuitive to me. Um, I also have read a lot about the multiprocessing that Python has to offer, and I've tried it myself. But I find it to be not very intuitive, especially when you compare it to how easy it is in Go. Um, the kind of shining light or the little beacon is that because Python is so widely used, it can make use of a lot of frameworks that might be run or written actually in other languages in the back end. PySpark is a great example of that. TensorFlow also. And so I think when I was looking at scaling, Go and Julia kind of take the biscuit with this one. Okay, readability and ease of use. It's difficult for me to really say much negative about any of these languages when it comes to readability and ease of use, but there are some quirks. So Go aims to be simple and uniform. I found it particularly easy to pick up. It compiles into one single executable that runs standalone, and even packages go inside itself. It makes it really easy to deploy on Docker or Kubernetes. One of the issues that kind of haunts this language is that the generics are virtually non-existent or are non-existent. It's been coming for maybe years now, actually. So that's definitely proven to be a challenge. The reason why you might, for people who don't or haven't used generics before, who might come from different background, is that things like a math.max function will only work on doubles. So this is a case where you can't genericize the math function for all types of numerical variables, such as integers. And that, when you extrapolate that to other bigger problems, can become really painful. From a Julia point of view, again, really easy to use. You can use it in Jupyter notebooks as well. Has nice IDE. One of the big selling points of Julia was also that it interfaces nicely with Python, R, and MATLAB. But the issues around this language is that I've heard people say, yeah, maybe it's just another spaghetti code academic language, which I found not particularly nice to hear. But I kind of, having worked in many different academic teams running and deploying and developing data science projects, I can sympathize. One of the most unfortunate things about Julia is that it indexes at 1. I don't know why they made that decision, but it's something that I still struggle to forgive them for. And Python, so nice IDs. I put readable with a question mark, and I'll come to that in the issues. But I think there's no doubt that it's super quick to get something. Now, the challenge for me is that I don't need to get something. I need to get something that I can reliably productionize relatively swiftly. And I think that's where I get the overhead of Python sometimes. Um, when speaking to a few of my colleagues and friends about this particular uh, part of my presentation, almost everyone had a small war story about, oh yeah, I tried to do this, and then this bug came back later that if I had a typed language would have been fine. Um, but the other thing that I heard was that there's just so many choices and so many options that it's got to the point where you join a new team and you kind of have to learn what that team likes to work with. So you might have to learn a bunch of new packages that you haven't used before. When you read someone else's code, they might have written it in a way that isn't instinctive to you, even if they've followed, maybe PEP 8 or something similar. And so the final part of that story is that if you do have to learn those new packages, um, if the documentation isn't as great as we would all like, then you can often end up struggling to figure out what the function is doing. This is partially because you don't necessarily know what objects it can give back, and you don't necessarily know exactly what it can take. And that's due to that dynamic typing. So this is a few small code snippets I put together in case anyone was interested or hasn't used these languages before. I just made some super simple functions that essentially select a random um, object from an array, although you could argue, is it a list array or a sliced in this case? I think array kind of covers them all almost. So Go looks like the most verbose in this case, but you can also see that half of those lines are just taking up with the defining the package name and the imports. But inside the function, they could all be one single line, but I think 3 is quite legible. Okay, and then onto my kind of final criteria, which was data science support. And this is where Go fails miserably at the moment. Um, I think that there's a lot of academic debate about whether we should be building our data science models from scratch or from using a few tools. Um, but the fact of the matter is that there's a reason that Python scikit-learn is so popular, and it's because you can try out models that you maybe haven't tried before. You can also see loads of nice examples, and it's very quick to implement stuff that you have used before. There's no real established high-level libraries in Go. Um, and so I think that it's still early stages. I think that the generics problem that I mentioned earlier might be part of the problem here, because you can't generically define a kind of trainable model. There was a really nice response to a question about the future of machine learning in Go on Reddit that pops up on Google if you do the search, but I've added it to my presentation in case anyone's interested. And it kind of outlines a lot of the libraries and the challenges that they're facing, but also looking for support to develop more. Julia has multiple implementation of common machine learning algorithms, and it kind of is trying to adopt the scikit-learn framework. So it has a scikit-learn.jl, which is using a lot of the kind of popular Python machine learning algorithms, and either some of them are rewritten in Julia to be quicker, and some of them are just kind of calling out. I mentioned before that Julia is kind of known for interfacing well with Python and R. So if you are missing something, you can typically just add a function that you might love from a language that you know better. And Julia's been developing its own TensorFlow. It's not something I've tried, but I know that there's some good evaluations of Flux online. And finally, Python. Well, it's probably the most popular language used for most machine learning applications nowadays. It has extensive libraries, makes it a really obvious choice when you're starting a data science team or machine learning. TensorFlow, I guess, and a few other interfaces that I mentioned earlier, or frameworks, work really nicely and play with the Python very well. So the only thing that I think is worth a mention is that when you do get multiple data scientists coming from different backgrounds, you sometimes end up with both Python and R projects in the same company, and that can prove quite challenging to maintain over time. And I think that's just maybe a strategic thing that you have to deal with. So I guess this is where I round up my conclusions. Um, the first thing to say is that all of these languages are easy to pick up and use, and that makes them a good candidate, especially for small companies, and even more so if they are young languages, because the last thing you want is to pick up Go and then have to spend many weeks learning how to write it, and I haven't found that has been the case at all. So what's Go great for? Speed, scalability, structure, ease of development, and I found that there's enough support for the software, but certainly not for data science yet, at least. Julia, I think that the biggest challenge it's facing is that it's not growing fast enough in adoption. It's really quite impressive when you look at the speeds compared to Python and R, and it does have good data science support. And then finally, Python, huge adoption, massive amount of support, and I do believe it's getting faster. So after that kind of evaluation, we decided that we wanted to use Go for our runtime software, but benefit from some of the data science capabilities available in Python and Julia. So we came up with a kind of combined solution, which is a little bit different from combined solutions that I've typically done before. And this is what it looks like. So you can see that our main software module is written in Go. That's in the blue step. You can start blue square A. During our program, we write out to disk some of the data that we've already processed. Now, what's key here is that we actually do a lot of the feature generation in Go, even if we maybe discovered some of those features offline. And what that does is it means that the data that we send over is the data that we would also be able to apply a model to. So we keep as much of that computation in this fast language. And then in the offline training and exploration, we can ingest that data, train the model, tune the model, we can explore it, we can potentially look at adding other features. But for the day-to-day running, this can run anytime, it can be any speed, and it can be written out to disk at any time. So all that happens is that the model will get replaced with a newer version, and then our runtime software can pick up that new model and actually implement it in Go. So there's this super nice library, and there's many others. We were looking particularly at like GBM and XGBoost, and this library Leaves was developed in order to be able to read models that were trained in a different language, but be able to apply them in Go. So actually our runtime is all in Go. And that's it. So I don't know if there's been any questions in the meantime, but
hi, Alex. Thank you so much. Yes, we do have a lot of questions. Thank you for your presentation, Alex Ridden. So the first question is from Kayetan, and he wants to know, are these benchmarks showing results of default Python library, or maybe they use a C-optimized libraries like NumPy, Cython, or Numba?
No, that's a good point. So I can give you a link to the benchmarks that I used, and maybe we can look a bit further. What they say is Python 3, so I don't know if they also use some of these C-optimized libraries, but that's a good point. Yeah.
Okay. The second question is from Kante Kamel, and is asking about index from 1, probably because of MATLAB.
Yeah, I think so too. I mean, that's the only obvious reason why they might have kept that. I think they also took a lot of their syntax from MATLAB. That's what I've heard. So.
And again from him, he's wondering whether there is another Spaghetti Code Academy language. Where do you see Python in the next 5 years?
Oh, that's a tough one to say, because Python, from my point of view, I think for my use case, I'm going to be obviously trying to transfer to a different language. But when it comes to Python, has so many other use cases that I couldn't speak on them all. I don't see it going anywhere anytime soon, and you can see that its growth hasn't slowed down; it's only got faster. So.
Okay, we do have another question, and is from Fabian, how is finding documentation or certain solution on the different languages?
Yeah, so I think that that's quite well reflected in the graphs I showed about Stack Overflow. For a majority of the problems I've faced, I've definitely found at least partial solutions. I think Python, weirdly, I sometimes get challenges because there's so many old versions of Python now, and there's multiple different ways of solving the same question, that sometimes I think I get a solution quicker in Go because there's less options. Yeah.
Okay, we do have another interesting question, Alex, for you. What kind of advice would you give to a young researcher in the field of data scientists?
I think it's important to have breadth in the challenges that you try and solve. It's very easy to go down a route of like only solving regression type problems. But I think early on, it can be really valuable to try your hand at like deep learning problems that's really much easier, much more accessible now than it was, let's say, 5 or 6 years ago. Try your hand at looking at images, try your hand at classification problems. It's like that experience, that breadth of experience early on means that you can choose to kind of specialize and get depth in one of those fields later, I think. Yeah.